This is Lab 26, Example 4. We want to identify the degree, the leading coefficient, the zeros with multiplicities, and sketch the function. We have the function y is equal to x minus 2 squared times x plus 2 squared times x minus 4 squared. So first we're going to identify the degree. We're going to represent that by n. That's going to be our number of zeros, or we could also say that it's the if we multiply this all out, it's the exponent of the biggest x, the very first term. So we have two zeros here, since this term is squared. We have two zeros here and two zeros here. So adding this, 2 plus 2 plus 2, we have 6 zeros. Or in other words, if we multiplied this, we have x times x times x times x times x times x, and that would give us x to the power of 6. So our degree is 6. We want to know what our leading coefficient is. I'm going to represent that by A. Our leading coefficient is the number in front of our x with the biggest exponent. So again, if we did x times x times x times x times x times x, that would give us a positive 1 in front of that x to the 6th power. Since there's no number in front of any of these x's and they're all positive, our A is going to be 1. So moving on, we want to figure out what our zeros are and their multiplicities. So to do that, we're going to set this y is equal to 0. We have 0 is equal to x minus 2 squared times x plus 1 squared times x minus 4 squared. And this will remain true if either of these zeros are equal to 0. So if we have 0 is equal to x minus 2, we have x is equal to positive 2. If we have 0 is equal to x plus 1, then we have x is equal to negative 1. And if we have 0 is equal to x minus 4, then we have x is equal to positive 4. I almost wrote 0 here. So we want to figure out what our multiplicities are. So our multiplicity for our zeros, x equals 2, is going to be 2, since we have 2 of this 0. For x equals negative 1, we're going to have 2, since again we have 2 here. And for x equals 4, we also have 2 here. So the multiplicities for all of our zeros are 2. They're all even. So because of that, we know that in our graph, in our sketch, we're not going to be passing through the x-axis at all. So we're going to sketch our function, and we're going to write down what our zeros are. We have a 0 at negative 1, we have a 0 at 2, and we have a 0 at 4. And see, we know that our n is 6, so our degree is even, and A is 1, so it's greater than 0. So because of that, from this table, we have A is greater than 0, and we have an even degree, so our graph is going to be up on the left, and it's going to be up on the right. So we're going to be coming from the upwards position, and we're going to be ending going up. And because all the multiplicities are even for all of our zeros, we're not going to be passing through the x-axis at all. We're going to be bouncing off. So going down to negative 1, we go to negative 1, we bounce off because, again, the multiplicity is even. We bounce off, and then we want to go to 2, which again we're going to bounce off, and then we go to 4, which again we're going to bounce off. So this is a little quick sketch based on what we know about it. It probably will look a little bit different if you actually graphed it in real life, but this is how we can graph it, just a quick sketch of what we know from this information.